We're going to do two things today. We are now done with section 3.3. We're going to change gears a little bit today. We're not going to focus on the graph or the domain or the range or the behavior of a graph of a function. 3.4 is about composite functions. And the first thing I'm going to do, you either need to have your cell phone out or your laptop, whichever one you prefer to use. I'm going to pull up a PowerPoint, and you guys are going to get a chance to vote your answer. Like they do on Who Wants to Be a Millionaire? You guys remember that show? So we're going to poll the audience here. We're going to do it here in about 3 slides. So I'll alert you when we're ready to do that. Composite functions. I got a little picture here for you. Actually, I have 2 of them. I'm going to show you the first one. A composite function is just a series of more than one function. So, for example, this would be my domain over here. My input all my inputs would go here, and all my outputs are going to be on the far end. But notice that we don't have just one function. It's actually going through 2 functions, right? So if I have some x value here, that x value is going to go into a function which is named g, and on the way out it'll produce some y value which is g of x. That's our output. But then notice that we're not done. This output then is going to jump into a second function, whatever f does to it, and then produce the final result. So our input is being manipulated twice, if that makes sense. I actually like this picture better. It's saying the same thing. This gives an actual example. What happens if 3 was a member of your domain? 3 goes into the function x squared. So 3 squared is 9, so it would spit out 9. So f of x equals 9. But then we're not done. Now we're going to go into a second function. So 9 goes into g, and that function says to take x plus 1. So our final answer would be 10. So if you look at the very bottom, the g of f of 3, notice how I said that, g of f of 3 is equal to 10. And it's what we call a nested function. So I'm looking at this part right here. Notice that f of x is on the inside. F of x is on the inside. And then we did the g of that. It's what they call a nested function. So our order of operations say we start from the inside and evaluate that function, and then go to the next one, and then go to the next one, and the next one, and the next one. So if there was a third function, I could have said, maybe I would have had a third box, which I don't, but I could have. Maybe it would have said the h of g of f of x. That would have been a third function called h, and I can make a 4th one, and a 5th one, and a 6th one, and whatever. Okay? So, here we go. This is where you need your device. So, what you need to do, if you are using your computer, go to this website, pollev.com/JamieWorth189. If you want to use your cell phone and you want to text your answer, then you got to send a text message. The number you are texting it to, like the phone number or the person's name, would be 37607. Don't worry, I'm not going to see your cell phone number. This is all through internet. So you would text the message JamieWorth189, and you'd send it to the phone number 37607. So I don't care which way you do this. If you want to use your phone, use your phone. If you want to use your laptop, use your laptop. But what should happen is, as soon as you get on this website and you do this, it should pull up this question, and then you got to answer A, B, or C. As soon as you do the text, within like a second, it'll tell you that you're in. Did anybody do it on their phone? And once you're in, then your next message would either be A, send, B, send, or C, send. So we're just voting on an answer here, okay? So far, 2 of you have voted. So you got to read the question, which is up in the blue. This can turn your brain around a little bit. So you might want to have a piece of scratch paper out if that's going to help you. You got to read this very carefully because this can be confusing. The question is, What does the C of S of 3 represent? That's our final question. What is the C of S of 3? I see 3 of you have voted so far, so figure it out and vote within the next, 30 seconds, 45 seconds. Only one of them is correct. A, B, or C. Anybody having any technical issues? Or are we all ready to vote? Did you have to clear your response and do it again? Did you figure out how to do that? Does it let you do that? Yeah, it'll let you do that, right?
It'll let you change it.
Yeah, you can change your answer. Okay, I see 13 people. How many we got here today? 4, 6, 10, 12, 15, 17, 24. Oren, did you vote or no? No? Okay. 7, 12, 13. We should have 24 people vote. We're at 20. We're at 21. As soon as that hits 24, I'm going to hit it. If you haven't voted yet, please do so. Oh, now we went to 23. There's 24. Okay, I'm going to show the results. Most of you said C. Some of you said A, some of you said B. Okay, let's talk about it for a second here. A good thing to do here that might help you would be to write down what your variables are, because if you get so many variables going on, sometimes it's hard to remember, right? So C represents what? Calories. S represents what? Sit-ups, number of sit-ups. And T is minutes. Okay. So how about the 3? Is that a calorie? Is it a sit-up? Or is it a minute? The 3. The 3 is the time, is the minute. So 3 is the minute. So what is, try to look at just the S of 3 first. Ignore the C. Ignore the outside one. Just look at the inside. The S of 3. 3 is minutes. So the S of 3 would tell you how many sit-ups a person will do in 3 minutes. Right? So this part will produce sit-ups. Okay? Now that we have a number of sit-ups, which we call S, sit-ups goes into the calorie function and produces calories. So our final answer is going to be labeled what? Final answer is calories, which were done in 3 minutes. So if a person does sit-ups for 3 minutes, he will burn C calories is correct. Those of you that answered C, correct. Does it twist your brain a little bit? I hope so. It's supposed to be challenging. Okay, let's try another one. Next question. Here we go. Suppose f of x gives the miles that can be driven in x hours, and g of y gives the gallons of gas used if you drive y miles. Which of the following is the most accurate? So this is saying one of the functions is meaningful, like it makes sense, and one does not. This one says the other one is meaningful and does not. One makes sense, one does not. This one says they both make sense, and then the last one says, this one says neither of them make sense, and this one says both of them make sense. So get your variables straight in your brain and take a vote when you're ready. Is that big enough for you guys to read in the back here? It's not too bad. Notice one of them is f of g of y. The other one is g of f of x. Again, you might want to write down what your variables are. What is x? What is y? What is f? What is g? Got 14 voters so far, need 10 more. Whoa, whoa. Oh no. Are you guys still able to vote? Didn't kick you off? Oh shoot. Darn it. Did that screw any of you up? Or are you still able to vote on this one now? Are you good? Okay. So it was just on my end then. Okay. Let's see if I can do this without my PowerPoint locking up. Show results. Whoa. Lots of disagreement here. Does anybody have extreme confidence that they think they got this thing right? Nobody? Nobody's confident. Okay, let's label our guys. X is hours, right? F is miles. Y is miles. And G is gallons. So let's look at the first one. F of G of Y. Do the G of Y first. The G of Y gives us gallons if we drive Y miles. So miles goes in, gallons comes out. So G of Y, this part on the inside, is gallons. Can I take gallons and put it into F? Or is F not designed to handle a domain of gallons? See what I'm asking? Can I take gallons and put it into F? What am I supposed to put into F as the input? Hours. F is designed to take an input of hours and spit out miles. Can you take gallons and put it into F? No. So what do I know about the F of G of Y? It doesn't make sense. You can't do it, right? And everybody's starting to change their answer here. Okay, what about the other one though? What about G of F of X? Does that make sense? So just focus on F of X first, on the inside. Miles goes in, what comes out? I'm sorry, hours goes in, miles comes out. So F of X produces miles. And what am I supposed to put into G? Miles. Does it make sense? Yes. So what's my answer? B as in boy. Should have been where you were at with that one, right? Okay. Let's try another one. Let's see here. Okay. This time we're just taking it off of a table. Up in the blue bar. Evaluate the f of g of 3. You got to do your order of operations correctly here. And you got to use the table. This is the input, and then these two are the outputs. When you guys do it on your computer, can you see the question? But when you're on your phone, you can't, right? Like it's a blank text message and you just have to text it. So using your computer is actually nicer if you want to have the problem right in front of your screen. Okay, only 8 voters so far. Got to be able to understand how to read the table. If x is this value, then the function f takes on that value, or the function g takes on that value. Another thing that might help is if I were to write the word input here, and then these are outputs, out and out. We're only at 15 voters. I thought this one was easier than the last one, but maybe I was wrong. Two more voters we need. Oh, why does it do that to me? Darn it. Okay, we're going to let my computer figure this out in a few seconds. Oh my. Sorry for the technical difficulties here. Okay. Somehow we got 25 voters. Oren, are you playing along now? I'm not sure how we got 25 voters in, but show results. Most of you said A. And everybody who didn't say A is changing their answer really fast. A is correct. A is correct. So, remember we're going to start from the inside. G of 3. So, our input, our x value is 3. So find 3. What is the g of 3? The g of 3 is 2. So now, since this part is equal to 2, now we want to take 2 and we want to put that into f. So go to an input of 2, put it into f. Our final answer would be 8. Okay, let's try another one. Same table, except this time we want the g of f of 3. G of f of 3. We're switching the order of g and f. That's the difference here. I'm going to let you guys watch the voting as it takes place. You guys can see what other people are voting. Don't let that influence your answer, though. Oh, wow. Everybody's on C here, huh? Everybody thinks it's 2? G of f of 3. If I put in the f of 3, I get 3. If I put in the g of 3, I get 2. Correct. Very nice. Let's try, I think I got 2 more. Okay. This one, it might be hard for you to see the screen if you're using your phone. We want the f of g of 1. F of g of 1. But instead of a table this time, you get a graph. If you're using your phone and those numbers are too small to see, feel free to walk up here and look at it. Most of you are on C here. You think it's going to be 6. So first we got to figure out what's the g of 1. Well, the g, that's the first graph. If I plug in 1, it looks like I get 3. So the g of 1 is 3. So that means I want to evaluate now the f of 3. If I go over here to 3, it looks like I should get 6. So I'd say C is correct. One more. If the f of t is t squared minus t, and the h of x is 3x plus 2, what would the f of h of 1 be? Most of you think it's 20. A lot of you put 25. If I put in the h of 1, I'm going to ignore f for the meantime, just h of 1 first. I always start from the inside. I'd take 3 times 1, which is 3, plus 2, which is 5. So the h of 1 is 5. I take 5 over to f. I plug it in. 5 squared is 25. Minus 5 is 20. So minus t. T squared minus t. So it'd be 25 minus 5. Yeah. Attention to detail. Okay. So, thank you for playing along. That's the end of that PowerPoint. I drew a little picture up on the board here. And actually, I should do it this way here. Do this really quick. So my online students can see this a little bit better. I need a pen. Okay. If I told you that f of x equals 2x plus 3, okay? And if I gave you a domain, that's my first little cloud of numbers, a box represents the function, and the other cloud is the range, the output, and I told you that this is f right here. If I put in 10, what do I get out? 23. That should be pretty easy, right? You guys agree it's 23? So sometimes what we can do is we can take a function and we can decompose it. Break it into smaller chunks. So what happens if I wanted that same action, 10 giving me 23, but instead of writing f of x as one function, what happens if I wanted to write it as two pieces? Two pieces instead of one. I still want it to go from 10 to 23. What could function number 1 be? Can you see the two pieces? Order of operations. What did I do first? Go ahead, Kiana. 2 times 10. So do you guys agree that if I did 2x as my first function, 10 would go in and it would produce 20? So now I got 20 coming out right there. What do I want then in the second box so I can get to 23? Not just 3. It's got to be x plus 3. Because this is now my new x value. It was an x value here. It turned it into a y value. But then it turns back into an x value when it's going into another function. So I'd want x plus 3. So this is two functions. I could call this one, say, f and this one g, something like that. This is two functions that produce that, whereas this is one function that gets to the same place, right? I could go the other way. Let me do the two function one again. I'm going to make up something different. What happens if this one was, say, 3x, and this one was x divided by 2? And let's say I put in, I'll do 10 again. 10 goes in. What do I get here? 30. 30 goes in, and I get 15. You guys see how I did that? I did it in two functions. Can you visualize what it would be if I tried to combine those two into one function? One box instead of two boxes. I still want to accomplish the same thing. I still want 10 to go in, and I still want 15 to come out. What would go in that box? 3x over 2. You guys see that? Order of operations says I would take the 10 in there. 3 times 10 is 30. Divided by 2 is 15. So that would be like taking 2 and composing it into 1, or I could take 1 and decompose it into 2. I could take 1 and decompose it into 7 if I had enough steps in there, right? Okay. I'm going to give you a worksheet. This is what your assignment is going to be for Monday. So when you come back Monday, and we've got about 9 minutes of class time to work on this. So let's get started. You can get the first couple done here. And I'll remind you again that if you haven't done your card sort matching, you should give that to Oren. One note on that card sort, it was worth 5 points. A few of you got like 4.5 or 4.75, and that's because we were really picky on the one. I'll give you a copy here, too. We were picky on that one that said, write your own story for the graph. Some of you wrote a story that sort of matched the graph, but you didn't quite use the amount of detail that was needed. So I'll point at our standard number 6 back there. Attend to precision. I can discuss and explain clearly the decisions that I make. Some of yours were a little ambiguous or were maybe missing a little bit of information that didn't quite match the graph. And if you want to ask about that, flag me down after class and I'll look at it with you, or Oren can look at it with you. And we can give you a suggestion on how maybe you could have written that a little bit better. Okay. This guy here, successive discounts. Go ahead and just read the directions. It's pretty self-explanatory. Notice that the first 3 are dealing with a pair of jeans that's $36. Once you get down to number 4, I'm having you ignore the fact that the jeans are $36. They're not $36 anymore. Starting on number 4, the price of your jeans is X. It can be any price. Okay? So the first 3, standard number 2 says reason abstractly and quantitatively. The first 3 you are reasoning quantitatively. For 4 through 8 you are reasoning abstractly because you're using the variable X instead of an actual numbered price. Flag me or Oren down if you have a question on any of this in the next 4 minutes. Online students, you will find this underneath 3.4 Composite Functions. 3.4 Successive Discounts is the document we're looking at. Online students, you can either print this out and type or write in your answers with a pen or pencil and then scan your document, or if you choose to type directly into the Word document and then save the Word document to your shared folder, you could do that as well, whatever works easiest for you. see how we did on the first two. What did we get for number 1? $23.25. Are we in agreement? How about number 2? $22. So the fact that your answer for number 1 and number 2 are different should help you answer number 3. And it should also help you finish the rest of this worksheet. If you want to stick around and work, you are welcome to. If you want to take off a few minutes early, you are welcome to. Come talk to me if you have any gradebook assignment issues or questions. Otherwise, have a good weekend. See you on Monday.